Good afternoon, sir. Sorry for being extremely late.
I was wondering if I had to take up the device and look to see if class is at 7 tonight. Because I'm saying, um, I don't understand. Everybody just ditch me tonight.
No, man, I literally just stepped in.
Yeah, but you are literally the first person to class.
Whoa.
That's the point I'm making. You're literally the first person to class. We're going to wait until the others come. If not, we can just have a conversation on what it is that you research. As a matter of fact, do me a favor. Just look at what it is that you've done, and for the well, I mean, you can take a 5 or so to get yourself ready for class, and then you can just look back at what it is that you've done, and then we can have a conversation on the areas that you look at, the BOD and the COD,
Yeah.
and then we can just talk more about it, right? So fresh up yourself, and then we can come back.
All right, no problem.
Cool. Let me know when you're ready. Hear me, Keith?
Okay, so yeah, man, I'm ready when you're ready.
Come on, I'm waiting on you.
Yeah, man, I'm ready.
All right. All right. So you, based on what you presented on, all right. So what on Tuesday? Um, what is it that you understand from the tests conducted on the BOD and the COD? Do you know the difference between the two? You know, yeah, what do you understand from what it is that you've done? Not sure if you're hearing me.
Yeah, I'm hearing it. I'm hearing it.
Okay.
So, all right. So, BOD, the test basically is just measuring the oxygen requirements for microorganisms decompose organic matter, and in doing so, you would basically, if you have a high, it's an all right. So it is a aerobic process, meaning it requires oxygen, and
Yeah.
if you have an increase in the level of oxygen, then it simply means that there is more organic waste that is being broken down, and it
And
means that there's
how is it that it's the BOD is doing that though?
how is it that it's doing that?
You're breaking down all the stuff by oxidation.
By oxidation.
Right. So the biological oxidation oxidizes the natural organic residues and the organic waste in the water. So just remember, so the BOD, so you said it's an oxidation ability. So the BOD is going to oxidize natural organic residues. But what is oxidation though?
So, roughly, I think oxidation is where there is a loss of electron to gain oxygen electron, or oxygen. No, electron. No, it would be electron.
Yeah, man. So oxidation is a loss of electrons. So one of the things that I want you to write this down for me, please. Oil rig, OILRIG. Capital
OIL.
OIL, right? On one side, and the other side, right? Capital RIG.
RIG.
Yeah. So oil rig. So oil, OIL, is oxidation, is loss. And RIG, reduction, is gain. So during oxidation, you are going to lose electrons. And during reduction, you are going to be gaining electrons. All right? So oxidation is a loss of electrons, but it is also the gaining of oxygen or the addition of oxygen. So during BOD, when you have oxidation taking place, you're actually adding oxygen molecules to it. So you're losing electrons, but you can also do the addition of oxygen. So that's why it oxidizes the organ, because remember, you know, these organic waste produces gas.
Yeah.
All right. And what it does, it oxidizes the production of gas, it causes the production of oxygen during the process. During the oxidation process, you're going to have additional oxygen. So the BOD now, so which is why now it measures the amount of oxygen. Did you say it measures the amount of oxygen available for microbes?
Yeah, for microbes.
Right. So that's why now, because during the process, during the oxidation state, oxygen is added. So the BOD now is measuring how much oxygen is available for the microbes within this water quality. All right. What the COD, on the other hand, what do you think the COD is or does?
It still speaks to oxidation, but it's not limited to organic.
Sorry, but before I go there, there's a point that I missed. So the BOD also in the production of it utilizes oxygen so that it can break down these organic matter in the water. So during the process, the addition of oxygen, it is going to be used now to help to break down these organic matter in the water. So the BOD now is to see here the plan, how much of this will have that the water can repair itself, right? Because it is going to be breaking down these organic matter within the water. All right. So tell me what the COD is, because one works one way and the other works the other way. So if we know that the BOD is going to be oxidizing, and providing oxygen for these microbes and to help to break down the organic matter in the water. In contrast, how does the COD work?
So the COD it requires, well, the COD it measures oxygen requirements, but
Right.
more
So that's what it does.
chemical. Yeah, it doesn't only work with organic. It does both inorganic and organic substance. So it will work on your ions. It will work on what else is inorganic? Paper. No, paper kind of organic that can break down. Like but
Right.
sir,
So
iron would be organic.
iron, like IRON?
Yeah.
No, it wouldn't be. But what it does is it measures the amount of oxygen needed. Right? So it's a measurement of the amount of oxygen that is going to be needed to cause the
The
oxidation.
oxidation. Yeah,
Right.
okay.
So
And the
it's a measure.
oxidation could be like nutrients apart from like organic matter. So like your phosphates and so
Right.
on.
Yeah. You know what is also true? For someone that has a swimming pool, and the pool is not used and you have all of this algae, um, and they are living and they are breathing up because they may have whatever stuff inside there. When you measure the oxygen content, the BOD and the COD, you recognize not that um, you know that there's a production of algae because you can see the green stuff and the water quality is really not good. So they put lots of stabilizers in there to not only kill the algae, but to restore the water to its to a good enough quality where it is that you and I can go in there and go swim. So what it does, it kills the algae and and stop the production of the algae. Then the algae now falls as a sludge to the bottom of the
The
pool.
water.
Right. And then now you are going to put your additives, and of course you have to put your chlorine. So it is that, but it don't have to be chlorine, it could be sodium chloride, salt. And so it is that now you are reducing the production of algae. So the water treatment has to be consistent because remember, water that is settled is the breeding site for many things, mosquitoes, algae, and you know, and other living creatures will just take it as a habitat. So you may have a frog who jump in there, a toad who jumps in there and say, "Oh, this is my haven," and then no, lots of things starts to happen. So it becomes a breeding ground. Now, if you if the water is not totally oxygenated in order to to serve, if the amount of oxygen is depleted in the water quality, then you're going to have stagnation, and then it's going to start to smell. So
Oh,
which is why all of this now needs to be treated in order for you to be able to restore aquatic and plant life. Because you see, what can happen also, is if you don't have enough oxygen in the water, the fish and the toad and all of these things will die. Not can, but they will die. You follow me?
yeah, yes, sir.
Yeah, man. So it is important. So therefore, which is why I'm saying what happens is the water authority, they will have to go all public pools, every one of them will have to be tested, and if it is that they find that the water quality is poor, they will also go and close down, because they have to restore it. What is also important is that the COD, the pollutants that are found in the water, the COD oxidizes those to carbon dioxide and water, oxidizes it to CO2 and water. All right. Now, the more CO2 you put in the water, is the less likely that you may have living creatures living there. Because
Yeah,
now it is that the fish them can't live in there, because when we have any oxygen going through their gills anymore, because the depletion of the oxygen level is there. You see what I'm saying?
yes, sir.
So yeah, so all of this here is and has become an important component, to do. So one of the things is that in order to carry out the COD test and the BOD test, the COD is a quicker test to carry out than the BOD. All
Yeah,
right,
that was I was just going to say that the BOD is over a few days, while the COD can happen within hours.
within hours. Right.
But sir,
Right. Yo.
so when the BOD happens,
Mm-hmm.
what is when it's oxidated? What is the product? Like where you have CO2 and water for the
Um,
chemical oxygen demand.
it 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 it
It's
it
just
doesn't give
oxygen.
you right. It doesn't give you the CO2 and the water. It's just a production of the oxygen because of the oxidation that takes place. The addition, yeah, the oxygen, yeah. It's just the oxygen that is produced. But also
Okay.
remember, that the COD is a strong oxidizing, uses a strong oxidizing agent, right? So when we're using the COD, we're going to use a strong oxidizing agent, and the strong oxidizing agent that is normally used is potassium dichromate.
Cool.
Now remember when I was writing the formula, the Cr2O7 is the chromate ions. So the potassium dichromate is going to be K2Cr2O7. All right. So K2Cr2O7, because the chromate anion is a Cr2O7 2 minus. Right. So if you have the potassium dichromate, it's a strong oxidizing agent, and that's what the COD utilizes. So in order to do this stuff, they have to put chemicals in there to help with to carry out their test.
Okay.
Right. Now, if I were really one of the things that I really want to do is I don't even know how it's going to be the
Dichloride or dichromate?
dichromate,
Okay.
potassium dichromate.
Chromate.
So K2Cr2O7.
K2Cr2O7. Yeah.
Right. So that's the formula for the potassium dichromate. It's purple in coloration, and
Very
it's a
purple.
very strong oxidizing agent. Now, the potassium
It look red.
dichromate, huh? It look red?
It look red here.
No man,
Was
it's
it's more
deep
it's
purple.
yeah.
It's when I said deep purple, it's very deep purple. And when we're doing like titration with the potassium dichromate, the coloration is going to be from purple to colorless. So, and guess what?
Oh
One drop of that acid can change it from purple, boom, to colorless. And then you know you reach your endpoint. When I was doing the titration,
yeah,
and
the
I
end
said
yeah.
the endpoint is on. So when you're doing this stuff now, so that's what we need to we need to do. So what I was thinking is that I know I can touch base with the NRCA and to get them to demonstrate how they actually carry out the BOD tests. I've never carried out a BOD or a COD test. I know what it is, but I've actually not carried out the stuff, and I know what they use. You know, like of course, I was talking to you about the potassium dichromate to actually carry the test and what it looks like, right? So I'm gonna see if I can touch base with. I'm gonna see if I can touch base with. Oh goodness. I'm gonna see if I can touch base with the. Oh, could call Natalie. And see if I could get a demonstration of an actual carrying out of the COD BOD, because it's something that is done on a regular, and especially water bodies that are that are sitting out there. You know, for example, when we have pollution, water pollution, it is it is the test that is carried out to make sure that things are normalized, and whatever corrective measures you know must be taken in order to restore. Follow me?
Yes, sir.
All right. So what I want to for you to do for me I don't know if you're in a position to share like the water cycle so we can have a conversation. I know we don't have much time to have a conversation about the water cycle now. Um, on what it is. If you could just find me the water cycle for me and then just project it so we can have a conversation. If that's okay.
Okay, no problem. Sorry about that, sir. I was trying to get back the audio. Oh,
That's all right. That's I heard you, but that's fine.
here it
Um,
is. Seen it?
yeah. But it's something with audio, or is us a pic?
No, it's just a photo.
All right, good. So let us see if we can just to show you now how the hydrosphere. Oh no, it's gone. Okay.
It's there?
Yeah, it's there. I'm seeing it.
Okay.
So as you can clearly see, it's a cycle, and the cycle now is just saying that things just go around in circles.
Yeah.
Let us start with our ocean evaporation. Let us start with our ocean evaporation. Hold on one minute. All right. So let us start with our ocean evaporation. Um, if you see in the corner of that, you see ice. The ice is going to melt to add water to the ocean. Can you see that?
Yes, sir.
Good. And then now you're going to have evaporation of seawater, don't it?
Yeah.
Right. And when you have the evaporation of seawater, um, the water molecule rises and sits in the cloud. You see that?
Yeah. Yeah.
When it sits in the clouds, when the clouds become saturated, means that it can't take any more water molecules, then it starts to rain. And the rain causes water now to go back into the ocean. Can you see that? Can you see that part of the cycle?
Yeah.
Good. What also happens is that you're going to have some of the evaporation that stays in the atmosphere. You're going to have some of the evaporation that remains in the atmosphere, and it is going to be hovering. So it's not all of the water molecules that go up into the atmosphere. It's when they all come down at once. Because remember, you have many clouds in the atmosphere, don't it?
Yeah.
And if one cloud is filled, then it has an opportunity now to fill the other clouds.
Yeah. Oh. Oh, that's why all of them are not having precipitation at the same time.
Absolutely, and that's why you can have rain on one avenue and no rain on the other
And on the
avenue.
other hand, yeah, Manchester, that man.
Yeah, man. Trust me. Trust me. I am driving and driving out of rain into dry land.
Yep.
And I was like, oh my goodness, but this was a storm. So you're actually driving out of something, or you could be driving into it,
Yeah.
right? So what is going to happen is that it's not all the clouds that will be saturated at the same time. Now, mark you, there are going to be times when you can have a super saturation, in cases where you have like an island-wide rainfall.
Yeah.
But what also is for sure is that the intensity is not going to be right across the island. You may have light showers here, but you may have heavy showers somewhere else. All right. Now, um, and then you can have some of the rainfall precipitating over ice, helping to melt some of the ice. I may have,
Yes.
of course, some of the precipitation taking place over the ocean, but as well you can have some of the precipitation taking place on the lithosphere, the land. All right. Now those are going to be falls into rivers.
Not hearing you, sir. Sir. Sorry, you still there?
Sorry, Mikey. You
Yeah,
know, one
hearing
of
you
the
now.
dangers. Yeah, man. No, one of the dangers of grabbing your phone to just decide to have a class on it is that it can ring and it is going to ring. So you know, I have a secondary phone that I use, but it as of late it's not really working so wonderful. So I thought to myself that, you know, clearly we are going to be in this online um, era related. So I may just need to purchase another phone specifically for this, so that when I'm having class, I can just read without any disturbance. But anyway, sorry about that. So you will have the precipitation now on land, and that is when it fill our rivers and our streams, you know, our little water catchment area, so forth and so on. And that too will also cause, you know, precipitation in order to refill our clouds, to saturate our clouds. But also the rivers, the dikes are going to flow back now into the ocean. You follow me?
Yes, sir.
So this is how now you have the surface flow going, right? Now, so you see one thing, and then you see one thing, and then now what is going to happen is that the water that gets on the lithosphere is going to also percolate into the ground. It's going to percolate into the ground, and that is going to help to feed our groundwater reserve. So you're going to have some groundwater flow, and that groundwater flow also gets into the ocean. So you see how cyclic this process is.
Yeah.
No, I don't. It don't end there because it. You know, one of the things that amazes me, you know, I love Jamaica. You know, I think as a nation we've done pretty well, you know, considering um, the resources that we have. But I remember when I was growing up, long before I decided that, you know, this is what I wanted to do. As a matter of fact, I didn't decide it. It chose me, not me choosing it. And because what I chose, I didn't know, it just never worked out. But one of the things that used to amaze me in the States when I was traveling when I was a little boy, I would see heavy rains and I would be very upset because I always wanted to go out. And it would rain heavily, heavily, heavily. And I'm speaking about Florida here now. But I'm going to tell you, no matter how heavy the rain falls, 10, 15, 20 minutes after, the road is dry. And I'm saying, but this not happening in Jamaica. Days before the water gets off, because their roadway is percolated so that water flows through. So when I speak about now the groundwater reserve, you know, you have the groundwater flow, Somebody may say, sir, no water no flow ground. It just evaporates from the ground and then the process start over. No, in the United States, it does. I don't know if you're finding that to be true, but it just percolated and it just goes right through and it flows, it moves, it no linger.
Yeah, that's
All right.
true. Yeah,
Um,
that's true.
yeah, man, the infrastructure is just very good. Now, um, one of the things though that also, hold on. So what is causing that? Strange. I'm sitting in front of a tank and I'm hearing it's more of a knocking sound on it. And I'm wondering if the fish was at the surface and them. I don't know. That was strange. I don't know what was that knocking sound a while ago. Interesting. But I'm not hearing it again. All right. Now, what is that process when water leaves the leaves of a tree?
Evapotranspiration.
Evapotranspiration, right? So look at what is happening over to the right-hand side. You see evaporation and transpiration taking place there, so? When you look at our vegetation, water is also leaving the lithosphere to help to saturate the clouds. You see that?
Yeah.
Life is just a cycle. Beautiful. And I don't care what nobody wants to say. I don't think I am a chance, or this earth was created by chance. It is well calculated by Father. Because look at the different sources of water. We have the ocean, we have ice, we have from our vegetation, evaporation, transpiration, water is leaving, and then as the water leaves and the clouds get saturated, we have land precipitation, we have ocean precipitation. So you have two types of precipitation taking place. Land precipitation is when it comes back down, right? It moves from over land and it moves over ocean. When the clouds are saturated, it falls, and then now you again are going to be watering the vegetation, and then water is going to be leaving them, and when water again, water is going to leave them. So what is happening when the water leaves, the nutrients, the minerals in there gets concentrated, and then when it are not moving, and then when you water the plants, no, it dissolves the minerals, and the minerals moves around in the plants, and the plants live and strive. So when you have like a carrot and you have like an Irish potato and you have like a callaloo and you pak chow and them something there, right? Your spinach and your kale and your lettuce. When it becomes dry, the sun hot and it becomes dry, they quail up and they move because the water is evaporating from the cells. So the cells have nothing, no life, and it just drop down dead. Oof. But the moment you sprinkle it with some water, what it is that you're doing, you're filling those cells again. The minerals are able to move up and down, and the plant looks good and say, wow, what a lovely bunch of callaloo. You ever see that yet?
Yeah.
Yes, man. It is just how the cycle moves and how it flows and how it goes. All right. So that's what I pick up from here. I don't know if you're seeing anything else.
Well, the percolation contributes to soil moisture.
Mm-hmm.
Yeah, which is important because soil is actually a living thing, and you need the
Absolutely.
moisture to hold it together.
And it is also a habitat for many supplying the ecosystem. You think of earthworms, you think of ants, lizards, grasshoppers, you name it. It's very important that we have that sort of moisture in it. And of course, the moisture is also very important because this is where the roots is the source of the intake of water. And also,
Yes, sir.
and I mean the plants also take water from their leaves, you know. So which is why when I'm watering my plants, I don't know. For example, for example, I am big on recycling. So big on recycling that all my plastics are placed in a separate container. Every one of them. Household plastic, plastic bottles. I do quite a bit of and I kind of feel guilty about that. I do quite a bit of like Gatorade bottles, Powerade bottles, all of those. They don't you wouldn't find them in a if it gets into the regular bin, it's it's in error. And if I do see it in there, it is taken out and displaced in a separate container. The liquid detergents, um, the cleaning agents, all of the bottles are placed in one big garbage bag. When the garbage truck comes, they get their separate stuff. No, we know that it defeats its purpose because when it gets the Riverton, everything go back in everything, right? And when fire come out, no, what is going to happen is that these bleach bottles and other detergent bottles are going to be exposed to the flames, and then you're going to have the chemicals, burning in the atmosphere, and then you're going to have chemical reaction taking place because if we have one chemical mixing with another chemical at this point in time now, and what it does, it makes it contributes to greenhouse gases, one, and two, it causes respiratory illness among those persons who are in close proximity. And matter of fact, not only those in close proximity, because the wind blows and it carries it miles away, don't?
Yep.
Because
Especially if you have a temperature inversion.
absolutely, absolutely. So if I am in Portmore, I'm not talking about like called Greater Portmore, and Riverton has its challenge. People in Greater Portmore sense it, and people who are living up in Jacksonville, Sherrill Gardens, and Riverton has their challenge. They are also sensing it. So the wind carries it. The wind carries it. Look at the Sahara Desert, the sand. Look how far that I come from. But at times we experience it here in Jamaica too. All right. So the wind has a lot to play in all of this. No, I say that to say to you that when I'm using the machine, the washer for argument's sake, very rare, and it's like in very recent times, the water goes into the septic. That in and of itself is not problematic for me because I think mine is very well built. As a matter of fact, I have two, and one of them is as new as the day it was built many years ago. And the main one, I recently drew it. And this was after about 20 something years.
Yeah, that's good.
But the soak away is excellent.
Yeah.
Right?
Actually, your solids being separated properly because unless fat and grease accumulating in it. That's really good.
Very good. So what happens now is that when I called the guy and he opened up and I was saying that I don't understand because I have a backflow of what is happening in the toilets, and I'm suspecting that the pit is full. And I called the guy and he was an honest guy. He opened it and come and say, Some other people that just open it and just put the hose in there and then run the truck 2 times until they say them get 2 loads. But brother, you have a good pit. The problem is that your inlet is too low. So that's what happens now. So if the pit is not full, but because the inlet is low, when you flush, the contents don't go down fully because the inlet is so low inside of the stuff. And this is just poor construction by the persons who built the pit, if it's what I'm saying. I guess I can correct it by running more pipes and just running it a little higher. But the truth is, it really don't pose much of an issue. So when the guy pull it up, him say, no, what I'm really pulling from it is just some sludge because the separation took place. And then what I did some years ago was to buy, oh goodness, I don't remember what it's called. Jesus. Oh Lord, I bought some treatments some time ago. I would call it a catalyst. I won't be wrong if I say a catalyst. I bought some treatment because of what I was experiencing. Went away, bought some treatment, and the treatment for me is to empty the sachet into the toilets. It looks, it's powdery and it almost looks like sand, and I'm going to flush it. Now, when it flushes it, what it does, it reacts with everything that is inside the pipe, from inside of the hose through the drain into the pit. When it gets into the pit now, it reacts with whatsoever is there and breaks it down and leaves some things as sludge, and the water is drained. And it works. When I say it works because all the guy was able to do was just to pull the sludge. And the sludge wasn't even a whole lot because you had very good reaction taking place in terms of the breakdown of the pieces, etc., etc. So that in and of itself is very good, very, very, very good. All right. So the water from the machine, I don't put down into the tank, into the pit. I have a barrel right by the washroom, and so when the machine is being used, instead of having a hose in the inlet, the hose is stretched on the outside of the washroom into a barrel that I cut out, drill out, and connect a pipe cock to, so that I could attach my hose. And what happened is that I attach a hose. So whenever I'm using the washer and I'm doing several loads, I don't know, after about 2 loads, wash and rinse. It depends on the cycle that I use. If I use an extra large, the barrel will almost be filled. All I do is just turn on the inlet and just put the hose into the yard. So what it does, I'm recycling my water. I'm not wasting it. So I'm irrigating the grass and the plants and so forth and so on, and pretty much just cooling down the place. What's the point I'm making is when I'm watering, I don't just water at the roots. I water the leaves because I'm aware that the water can also be absorbed through the leaves and help with the movement of minerals in the plants. All right. So it is just very nice. So when you look at the transpiration there, the evaporation, transpiration, it's good. One of the things that I'll say to you is you will need to know how to do a sketch of the water cycle. You will need to know the aspect of the water cycle. You will need to also be able to explain the water cycle, right? So I would say find you a simple version. If this is the simplified version of the water cycle you have, there are many different types of water cycles out there, or versions of it. Find one that you know, should in case they ask you to describe the water cycle, at least you can have it. Or sometimes you can talk about the hydraulic cycle. You can have it and you know how to sketch it, to put in your different points, and you speak about the water source, where it goes back, and you know how cyclic needs support and so on. All right. Anyhow, 7 o'clock, I'm going to stop here. Thank you for being the lone one today. I was wondering I was going to be the only one here, but thanks for saving the day. You have work. Review what it is that you did in the presentation, and also take up the water cycle and go through it. I'm not going to be long on this one because I want to be able to go through. There's going to be some, you know, water pollution that we need to look at and to see how this impacts the hydraulic cycle, the hydrosphere that we're looking at. So at this point in time, I'm going to say, big up yourself. God's willing, we talk next week.
Yes, sir. No problem. Have a
All right,
safe
so you too, Papa.